So let us solve the next problem. So we have to minimize z equals to 2x plus 3y subjected to these constraints using big M method. So what is the very first step? We have to balance the given constraints. Okay, here we have look at the left hand side, we have x plus y more than or equal to 5. So the left hand side is more than the right hand side, so let us subtract some positive quantity in the left hand side. Let it be s1. Okay, and look at the second constraint. So we have the left hand side is more than or equal to right hand side, so let us subtract some positive quantity in the left hand side so that it will be equal to 6. Let it be s2, right? So now we have to check the feasibility of this solution, right? So if I substitute x and y both are 0, what happens here? So we have minus s1 equal to 5, that is nothing but what? S1 equal to minus 5, which is less than 0. But here S1 is non-negative, but here S1 is negative, so which is not feasible. So at this stage we have to introduce an artificial variable. How? So let us see this. So x plus y minus s1, we have minus s1, let us write plus a1 equal to 5. If you have plus s1, write minus a1, right? Okay, fine. And look at the second constraint. So if I substitute x and y both are 0, what happens? So minus s2 will be, what happens here? This is one constraint, let us write it as it is. So here if I substitute x and y 0, what happens? So minus s2 equal to 6, which is nothing but what? S2 equal to minus 6, so which is less than 0, so which is not feasible. So in this constraint also we have to introduce an artificial variable like this. How? So with this is x plus 2y minus s2 is there, so we have to write plus a2, that is equal to 6. So this is one constraint, right? So now we have the objective function like this. So I told you earlier, for the minimization problem we need to write plus m times a1 and plus m times a2. We used two artificial variables here. If it is for the maximization problem, we need to write minus m times a1 and minus m times a2, and here m is a very large number. So we can say that the minimization of z under this constraint is nothing but the finding the maximum value of minus z under the same constraint. Okay, so let us convert the entire problem in minimization to the maximization. So minimizing z is nothing but maximizing minus z with the same constraints. So the maximization problem will be, so this is the maximization problem, just multiplied by minus z. Okay, fine. Now let us substitute the value of a1 as well as a2 here. So what is the value of a1? Look at this here, we used a1, right? So what is the value of a1? So let us shift all this term to the right hand side. So it is 5 minus 6 minus y plus s1. So 5 minus 6 minus y plus s1 plus, what is our a2? Let us shift this to the right hand side. It is 6 minus 6 minus 2y plus s2, right? Now on simplification we have, now let us write the coefficient of x, coefficient of y and coefficient of z as coefficient of s1 and s2 separately. So on simplification we have, this. Okay, so let us write the initial simplex table. So what is the initial simplex table here? Look at the constraints here. So the constraints, look at the first constraint, this is the first constraint. So what is the coefficient of x? 1, the coefficient of y 1, the coefficient of s1 is minus 1, the coefficient of s2 is 0, the coefficient of a1 is 1, and the coefficient of a2 is 0, and the quantity is 5. So look at the second constraints. So here the coefficient of x is 1, the coefficient of y is 2, and the coefficient of s1 is 0, the coefficient of s2 is minus 1, and the coefficient of a1 is 0, coefficient of a2 is 1, and the quantity is 6. And look at the table here in the first constraint. So we used s1 as well as a1. The preference will be given to the artificial variable. We have to write a1 here, and we used s2 as well as a2, so the preference will be given to a2, right? And to write the delta row we need to know the objective function. Look at the objective function. The coefficient of x is 2m minus 2. So we have to write minus times 2m minus 2. That is, if you multiply minus, what happens? It is 2 minus 2m, right? And look at the coefficient of y. It is 3m minus 3. Let us write minus 3m minus 3. That is 3 minus 3m. Okay. The coefficient of s1, we have minus m. Let us write plus m. The coefficient of s2 is minus m. Let us write plus m. And the coefficient of a1, a2 0. And the quantity here you have minus 11 times m. We have to write it as it is. Don't multiply minus 1 there. Okay. So this is your initial simplex table. So what is the next step? We need to identify the smallest negative number. Okay. So in the delta row, we need to identify the smallest negative number. So this is the smallest negative number. Okay. So this is your pivotal column. And later we need to calculate the ratio. So quantity by the pivotal column is y. So we have 5 by 1, so which is 5, and we have 6 by 2, which is 3. So among these two only we have to calculate the ratio. So among these two we have to identify what? We have to identify the smallest non-negative. Okay, so that is 3, right? And this is your pivotal row. The intersection of these two will be your pivotal element, and the corresponding variable is y, that has to replace with 8. Okay, so now what we have to write here? So in the for the first row, which is a1, and the a2 is replaced by y and delta, right? So what is the next step? So we need to make this pivotal element as 1. How can you make that 1? Let us divide the entire row by 2. So before that, let me call it as row 1, which is row 2 and row 3, r1, r2, r3. Now let us define r1 dash, r2 dash and r3 dash. Okay, fine. So we have to make this pivotal element as 1. How can you do that? Let us divide the entire row by 2. So r2 dash will be what? Which is r2 by 2. So which is nothing but 1 by 2, 1, 0, minus 1 by 2, 0, 1 by 2, 6 by 2 is 3, right? So later we have to, this is your new pivotal row. This is your old pivotal row. So here we have 1, we have to make this 0. How can you make this 0? In the new pivotal row we have plus 1, here also plus 1. Let us do the subtraction. So r1 dash will be r1 minus r2 dash, the new pivotal row. So 1 minus 1 by 2, which is 1 by 2, 1 minus 1, 0, minus 1, minus 0, minus 1, 0, minus 1 by 2, which is plus 1 by 2, 1 minus 0, 1, 0 minus 1 by 2, which is minus 1 by 2. So 5 minus 3, which is 2, right? So later I want to make this 0. How can you make this 0? We have 3 minus 3m here, and in the pivotal row we have plus 1. Let us multiply the entire row by 3 minus 3m, and let us do the subtraction. So we have 3 minus 3m. Here also we have, if you multiply 3 minus 3m here, we have 3 minus 3m. Let us do the subtraction. So we have so let us write that directly. You do the workout for this row operation. Okay, which is 3, which is 0. So look here. So we have 3 minus r3, right? So let us write that r3 as it is. What are the coefficient? 2 minus 2m. So 3 minus 3m, m, and m, 0, 0, minus 11m, and we have to make this 0, right? So look at the pivotal row here. We have 1. Let us multiply this row by 3 minus 3m. What happens? So 3 minus 3m by 2. What happens? It is 3 minus 3m divided by 2. And 3 minus 3m into 1. Right? And 3 minus 3m into 0. And 3 minus 3m into minus 1 by 2. Which is 3m minus 3 by 2. And 3 minus 3m into 0. And 3 minus 3m into 1 by 2, and 3 minus 3m into 3, that is 9 minus 9m. Now let us do the subtraction, right? Let us change the sign now, right? Here you have 2 minus 3 by 2, which is nothing but 1 by 2, right? And we have minus 2m minus 3 by 2m, that is nothing but minus m by 2, right? So here 3 minus 3m minus 3 minus 3m, 0, m minus 0, and m minus 3 by 2 m, it is minus 1 by 2 m, right? Minus m by 2, and here we have 0 minus 3, 0 minus minus 3 by 2, it is plus 3 by 2, right? And here we have 0 minus 0, and it is 0 minus 3 minus 3m by 2, which is nothing but 3m minus 3 by 2, and minus 11m minus into minus plus 9m, that is minus 2m, and 0 minus 9, right? Let us write that as it is here, right? So okay, so after that here we have to identify the pivotal element here. Okay, so among this row, the smallest negative number is m minus 1 by 2, right? And later sorry, it is 1 minus m by 2, sorry, it is 1 minus m by 2, right? So this is your smallest negative number, so this is your pivotal column. And how can you identify the pivotal row? Let us consider the ratio quantity by pivotal column x, so which is 2 by 1 by 2, which is 4, and 3 by 1 by 2, which is 6. So 4 is the smallest number here, okay, smallest non-negative number. So this is your pivotal row, so this is your pivotal element. So what's the next step? So corresponding variable x has to replace with a1, so here it is x and y and delta. So now what is the next step? We have to make this pivotal element as 1. How can we make that 1? Let us multiply throughout by 2, so that it will be 1. So 2 into 1 by 2, 2 into 0, 2 into minus 1, 2 into 1 by 2, 2 into 1, 2 into minus 1 by 2, 2 into 2, 4. And I want to make this 0. So this is your old pivotal row, this is your new pivotal row, right? So let us, in the old pivotal row we have 1 by 2, right? So let us multiply, and in the second row we have plus 1 by 2. Let us do the subtraction. Okay, so r2 minus r1, so 1 by 2 minus 1 by 2, 0, 1 minus 0, 1, 0 minus minus 1, minus 1 by 2 minus 1 by 2, which is minus 1, 0 minus 1, and 1 by 2 minus minus 1 by 2, 0, 1 by 2 minus minus 1 by 2, which is 1, and 3 minus 2, which is 1, right? In the next step, so we have to make this 1 minus m by 2 as 0. So how can I make this 0? So let us write that row as it is. The row is what it is, which is 1 minus, right? So now look at the pivotal row here. I want to make this 0, right? So let us this is your pivotal row. Let us multiply throughout by 1 minus m by 2. We have, now let us do the subtraction. So this will be what? 0. 0 minus 0 will be 0, and m minus m will get cancelled, and minus into minus plus 1, and 3 by 2 minus 1 by 2, right? Which is 1. Okay, so 3 by 2 minus 1 by 2, which is 2 by 2, so which is 1, and minus m by 2, minus into minus plus m by 2, which is 0, and 0 minus 1 minus m, that is m minus 1, and 3 by 2 m minus m by 2 m, that is 2m by 2, that is m, and minus 3 by 2 minus into minus plus 1 by 2, which is minus 1, right? And here we have minus 2m. Here if I multiply 2 here, what happens? It is 2 minus 2m, right? So minus 2m minus into minus plus 2m will be 0, and minus 9 minus 2, which is minus 11. Let us write this as it is. So now look at the delta row. All the entries are non-negative, so I can say that we are in the optimum simplex table. So what happens here is the optimum solution exists here. So x equal to 4, y equals to 1, and we calculated this maximum value of minus z. So x equal to 4 and y equals to 1, and minus z maximum is what? Which is minus 11. So minus z maximum is nothing but what is the z minimum? Let us multiply minus. So z minimum is what? Which is